We are getting ready to start our unit on electricity and magnetism, so let's get charged up to learn. Let's watch a PowerPoint presentation to get our juices flowing and start to build our knowledge. Matter is made up of tiny particles called atoms that have electrical charge. The nucleus or brain of the atom contain both positively charged and neutral particles surrounded by negatively charged particles. When an object builds up too much of one charge, it creates static electricity. Lightning is a form of static electricity. Have you ever rubbed a balloon on your hair and then pulled it away, taking your hair with it, or then stuck it on a wall? Static electricity makes that happen. All electrical energy can be converted into light, heat, and motion. Some examples are a light bulb, a stove burner, a car motor. This video shows how circuits work and how electricity flows through them. As you watch, please look and listen for the following important words to know and understand: open circuit, closed circuit, insulator, resistor, and conductor. With our knowledge of circuits, we will make two types of circuits: a parallel circuit, which has two or more paths for electricity to travel, and a series circuit, which has only one path for the current to travel. In a parallel circuit, if one path is closed, the electricity can still travel. But in a series circuit, if the path is closed, the flow of electricity stops. Time for a review. Let's check what we've already learned. Ready? Hint: use the word bank on the slide to help you. Question 1. A buildup of charges creates. Question 2. Electricity that can only travel through one path is a. And question 3. A circuit with two or more paths is a. Ready for the answers? How did we do? A buildup of charges creates static electricity. A circuit where electricity can only travel in one path is a series circuit. A circuit with two or more paths is a parallel circuit. Magnetism is a force where moving particles attract and repel. Notice that the title Magnetism is linked to a web source where you can find more information. All magnets have a north and south pole and a magnetic field that surrounds the poles either as an attraction or repulsion. Every magnet has a magnetic field where the force of attraction and repulsion are the strongest. The video explains how magnets work and what causes the magnetic field. Electricity and magnets can work together and form an electromagnet. An electromagnet is a coiled wire where electric current passes and creates a magnetic field. We use these every day in our computer drives, motors that drive ships, cars, and scrap metal movers. If you've ever used a flashlight that you can shake to light, electromagnetism at work. Here is a video that explains how an electromagnet is created to turn a propeller and shows how to make the propeller move faster by adding a second magnet. Time for our second checkup on learning. Hint: use the words in the word bank. 1. A magnet has a blank pole and a blank pole. Question 2. Like poles, blank, and opposite poles, blank. 3. What is an application for an electromagnet? How did we do? 1. A magnet has a north pole and a south pole. Like poles repel and opposite poles attract. What is an application for an electromagnet? Any one of these three: scrap metal mover, computer hard drive, motor. Well, hopefully you are charged to learn. So please turn to your shoulder partner and think of 3 questions that were not answered or a question of interest for further study about electricity and magnetism on a sticky note. Place your note on the board when you have finished. This PowerPoint can be found on your Google Classroom, so you may view it again and watch the videos and check out that link for magnetism.